Good morning everyone. I am Tanushri Garai from Civil Engineering branch, and today I am going to teach you your Theory 1 paper, which name is Structural Mechanics. In the last class we discussed about the types of analysis in case of truss member and how we will find out the reaction forces and the forces in each member of the truss. And today we will solve some numerical based on the method of joint. So here is your question. So the question is, determine the support reactions in the joints of the following truss and calculate the force in member BA and BC. So here is your figure. A, B, BC and AC are three members which appear a truss in which at joint A hinge support is provided and at joint C roller support is provided, and at joint B one horizontal force of 500 Newton is provided. The distance of AC is 2 meter. The distance of AB member is 2 meter, and the angle of joint C is provided as 45 degree. So first of all, we will find out the reaction forces, and after that we have to calculate the force in BA and BC member. That means this member and this member. So according to the procedure, first of all, we need to draw the FBD, that means free body diagram of the given truss. So here is your free body diagram of this structure. So due to hinge support here, we have to provide two reactions. One is vertical and another is horizontal, and in case of joint C, due to the roller support, we need to provide one vertical reactions here. So this one is the free body diagram of given truss. So first of all, we need to calculate the external analysis of the truss member, by which we can find out the value of reactions of this truss. So the reactions are AX, AY and CY. So first of all, according to the external analysis, we need to find out these three reactions for the truss member. So here, as per the help of equilibrium equation, we can find out these three reactions. So first equation is your summation of horizontal forces are equal to 0. That is, summation of Fx is equal to 0. So first of all, we can see the horizontal forces. One is here, that is AX, and another is 500 Newton. So according to the direction, we always take the right side reaction or the right side direction of the forces as positive and upward direction forces as positive. Similarly, the left side direction forces, we can take these forces as negative and the downward forces as negative. So these are the sign convention of forces or reaction. So that here you can see the 500 Newton along the right side of the direction. So that's why the 500 Newton should be positive in nature, and the AX value is direction of this reaction will be left side. So that's why we can take this reaction value as negative. So 500 minus AX is equal to 0. That is equal to AX is equal to 500 Newton. So one reaction calculation is completed here. Then comes to next equation, that is summation of Fy equal to 0. That means summation of all the vertical forces or reactions are equal to 0. So we can see in this free body diagram, AY is a vertical reaction and CY is another vertical reaction, and we can put and add this value according to its sign. So AY direction is downward, so that's why we can say this is minus in nature, and CY reaction will be upward in nature. So that's why we can take CY as positive. So the net summation of these two reactions are written as CY minus AY is equal to 0. Hence, AY is equal to CY. Then comes to last equilibrium equation, that is summation of moment is equal to 0. So, for simplicity of solution, we can take the moment about A, so that we can find out the moment for the truss along the point A. So here, to find out the moment about A, we can check out all the necessary forces or reactions about this joint. So here, one horizontal force is here and another one vertical reaction is there. And the AX and AY value should be 0 because it is connected to joint A. So that's why we can consider only this force and this reaction. Okay, so that's why we can put the moment about A with these two reactions. So first of all, for the 500 Newton, what will be the moment about A? So you can see this horizontal force, that is 500 Newton, give a hogging moment towards the point A. So that's why the moment sign should be negative in nature, and it will cover 2 meter distance from this point to the destination point. So that's why moment is equal to load into distance. So load is your 500 Newton and distance it will cover 2 meter. So that's why 500 into 2 is moment for this forces. And the sign of the moment should be negative due to the hogging moment. Similarly, this reaction, that is CY reaction, give a sagging moment towards the point A. So that's why the sign of the moment should be positive and it will cover 2 meter from the point C to A. Hence, the moment of CY reaction should be CY into 2. Hence, by putting the equation here, minus 500 into 2 plus cy into 2 is equal to 0. Hence, we can calculate the value of cy as 500 Newton. Now, if cy value is 500 Newton, then according to summation of Fy, we got cy is equal to ay. Hence, ay is also 500 Newton. In this way, all the reactions is calculated now. Next, we have to calculate the internal analysis. That means we have to find out all the forces of members, that is BA member and for BC member. Now, we need to provide the direction of the member and choose a suitable joint by which we can analyze the forces along the member. So here you can see we assume the joint D for the solution, and it is the appropriate joint by which we can find out the member forces. So we take joint B, and now joint B connected by two members, that is BA and BC, and one force is there, which is horizontal force of 500 Newton. So first of all, according to procedure, we need to draw a free body diagram of joint B. So here we will draw the free body diagram of joint B. So it should be look like this. So this direction represent the BA member. This one represent the B and forces of horizontal, that is 500 Newton, and another member, that is BC member, which is provided here. So we assume the BA member in tension and BC member in compression. So now comes to analysis part. So to analyze the member forces, we have to provide the equations of equilibrium, that is equal to summation of Fx equal to 0 and summation of Fy equal to 0. So first of all, summation of Fx equal to 0, that is summation of horizontal forces are equal to 0. So you can see the horizontal force, one is 500 Newton and another is FBC, which is the inclined member. So by resolving this member in horizontal direction, we can modify this force as FBC sin 45, and the direction of the force is towards the left side. So that's why it should be negative, and the 500 Newton should be positive. So that's why 500 minus FBC sin 45 is equal to 0. Hence, FBC is equal to 707.1 Newton, and which nature is compression in nature. So today this much. We will continue this problem in the next class. Thank you.